standard attention has a scaling problem baked right into it. Every token attends to every other token, so the cost grows like O of n squared in the sequence length. Double the context, and you quadruple the work, and on top of it, your key value cache just keeps growing longer and longer. Linear attention takes a genuinely different route out of this. It drops the softmax entirely, rewrites attention as something linear in sequence length, and the flash linear attention family is what makes that idea actually fast on real GPUs. Let's break down the whole trick piece by piece. Let's put these designs side by side and compare them directly. Softmax attention compares every token against every other one. That all pairs interaction is what costs you O of n squared, and it forces the model to keep a key value cache that grows longer with every token you generate. Linear attention rewrites the whole thing without the softmax. Cost becomes linear in sequence length, and instead of a growing cache, the model carries one running state of a set size, so memory per step stays constant during generation. Here's the recurrent view of what's actually happening. Tokens arrive as a stream, processed in sequence. There's no giant matrix comparing all of them at once. Each token shows up, contributes its information, and moves on, which is already a very different picture from classic attention. At the heart of it sits a running state of a set size. Every incoming token updates that state, folding its own information neatly in. Because the state itself never grows, it plays the exact role the key value cache used to play, but now with constant memory instead of an ever-expanding one. Reading an output is just querying that state. To produce the next token, the model simply consults the current state rather than scanning back over every previous token it has seen. No all pairs matrix ever gets built at all, and that is exactly where all of the savings come from. Naively, that recurrence is slow on parallel hardware. Chunk kernels fix it, processing blocks of tokens together the way flash attention did for softmax. Gated variants like GLA live here too, and this is the family we call flash linear attention. So what holds this whole approach together? It comes down to three ideas. Dropping the softmax is really the founding move here. Attention gets rewritten as a kernel, a recurrent form, and that one single change is exactly what unlocks linear cost in the sequence length instead of the quadratic blowup you started with. Constant memory is really the headline payoff. Carrying a running state of a set size means inference uses the same memory per step no matter how long the sequence gets, which turns out to be a genuinely big deal for very long context windows. Chunk GPU kernels are what make it genuinely fast in practice, but there's a catch. Pure linear layers can lose some recall compared to full attention. That's exactly why so many models go hybrid, deliberately mixing linear layers with a few full attention layers to claw that lost quality back. All right. Let's keep the four takeaways that matter here. Softmax attention costs O of n squared because every token attends to every other, and its key value cache keeps growing. Linear attention drops the softmax and rewrites attention as a recurrent form that is linear in sequence length. Instead, it keeps a running state of set size, so memory per step stays constant, and chunk kernels make it fast on GPUs. Since pure linear layers trade away some recall, many models go hybrid. If breakdowns like this are your thing, Standarity.com has a whole shelf of them waiting.